50% of ocean pollution is mobilized by this mechanism. And it's essentially when it rains, it gets washed off into the nearest water body. It affects the reproductive ability of the fish. And so essentially, you don't see them die straight away. It's genetically modifying the way that they function, and that affects them for generations.
Adhesh, hi. Thank you so much for joining me today. I really appreciate it.
Thanks for having me. It's lovely to be here.
So tell us a little bit about yourself.
I'm one of the co-founders of Guerilla. So we've created a retrofittable device that fits into existing roadside drains to capture pollution that gets washed away every time it rains. And maybe we can get into what runoff is right after. But yeah, essentially we are a spin out from Imperial College and the Royal College of Art.
Awesome. Let's dive into it. So what do we mean by runoff? And why does it matter?
Yeah, essentially, just to give you like the scale of the problem first before I get into what runoff is itself. I think even the US EPA published a research about this where essentially 30% of ocean pollution is mobilized by this mechanism that's called runoff. And it's essentially when it rains on most surfaces, most impermeable surfaces, it gets washed off into whether it's a roadside drain, whether it's the nearest water body, and there are various routes this takes place. So there's usually one where most modern cities have MS4 channels, where as soon as runoff washes over surfaces, this water goes into the roadside drain, which is the first point of entry, and then it goes into this MS4 channel that takes it to the closest water body. And the second way this works is essentially when it enters the roadside drain in cities that are slightly earlier built, you have the situation where it goes into a combined sewer where these drains actually lead to sewage entering into it as well, and then goes to a sewage treatment facility where it's treated and then left into the nearest water body. But the problem comes because of the fact that there's so much pollution in this water that when it goes straight into the water body, it's polluting the water to the extent that it's actually quite unimaginable. And yeah, there are various facts to talk about how crazy it is. I think it being the only mobilizer of tire pollution into water. And it's crazy because tire pollution is one of the largest terrestrial microplastic sources.
So you said tire pollution being the particles, chemicals that come off car tires and lorry tires are left on the road. So as a result, it relieves like a chemical, or it leaves actual sort of physical particles. And these chemicals and these particles then find their way into the water network through the sewers. Is that what we're saying here?
Yeah, no, that's exactly right. I think that's the best way to phrase it. And yeah, so essentially there are almost 300 different chemicals that are released into runoff, and this gets mobilized into the closest water body. Things like heavy metals, where you have copper, cadmium, zinc. You have toxic hydrocarbons. These are polycyclic aromatic hydrocarbons that generally are from tire pollution. And all of this just gets mobilized and goes into the nearest water body and starts disrupting the flora and fauna that's present.
Just going back to the point that you made at the start. So 30% of ocean pollution is mobilized from surface runoff. So these toxic chemicals, these hydrocarbons from tires and other pollutants on our roads, on our motorways, on our local roads, find their way into our oceans and are responsible for 30% of the pollutants. That's crazy, right? I mean, I'm sure that's one of these stats that people would underestimate. When we think of water pollution, we think of these sort of large industrial companies spilling into our rivers. We think of the oil spills. We think of the physical rubbish pollution like water bottles, etc. But I don't think you'd think necessarily, or so the average person would think necessarily, of surface runoff finding its way into the water supply.
Yeah, no, that's exactly right. And I think even when we started off working in this field, like I said, we are actually a spin out. So we started off as a group project as part of university. And when we started this group project, there was a very vague brief about it, where essentially we were supposed to find a problem and then come up with a design engineering solution to it. But it staggered us as well, because when you're younger, you're trained to think that rainwater is one of the purest forms of water
Yeah.
that's available and so on.
Yeah.
And it's crazy to think that is one of the ways that like so much of the pollution gets mobilized. And ocean pollution, 30% of it is right outside your window. Like every time you step outside your house, you can actually see it entering into the gutter. And that's something that we use as a marketing tool as well. One of the first samples that we collected, and this was like one of the pivot points when we started the group project, outside our studio at the time in South London, we had a road that was just a single lane road. And we just went and scooped up some of the water when it was raining on one of the days. And it's just murky, it's opaque, it's black, and yeah, it's disgusting.
And that's as a consequence of all of this, the scale of cars and lorries and congestion on our roads, right? It's
Yeah.
just entering into our flora and fauna. And you spoke about I guess, the sort of the main route. Okay, so the pollution occurs on the road surface. It's sitting there stagnant on the road surface. And you spoke about the two main routes there. So into the CSOs and then into MS4 channels.
Yeah.
So those are the two main routes off the road surfaces that then end up in the water supply.
Yes. So essentially, MS4 is where you have it directly connected, where a roadside drain is taken straight to the nearest water body, whether that's a river, whether that's a lake. It just depends on the geography of the area. And in the case of a CSO, for people who are not familiar with the term, it's essentially a combined sewer overflow. So combined sewer is the system where you have sewage as well as rainwater being led into the same drainage network, same pipes that go to a sewage facility. But the problem is the time that these combined sewers were built, it was so early on that you didn't have the population that modern cities have. And so, with the current population, the amount of water that actually flows through these pipes hit the peak very easily every time it rains. And that kind of floods your sewage treatment facility, which then leads to spillages, which are called the CSO events. Yeah, essentially all of it somehow or the other in both scenarios just ends up in the water body. And with runoff having comparable toxicity levels to raw sewage, it doesn't even matter that it's being mixed with sewage, it's just contributing even further.
When this water, these pollutants find their way into a CSO, then typically get treated, or does it find its way just direct into the water supply?
Yeah, so essentially, a part of the problem is the fact that there aren't regulations in most parts of the world around it. In the UK, there still aren't regulations for runoff being something that needs to be treated. In the case of combined sewer, because of the fact that sewage is being mixed with it, it goes to a sewage treatment facility. But yeah, in the case of a CSO, it's just dumped into the nearest water body. And yeah, essentially it's polluting. In the case of an MS4, there is absolutely no treatment. And that's where we come in as well. Our solution is trying to mitigate the fact that there is no treatment. And we are trying to mitigate the amount of these pollutants getting into the water. And part of why that regulation hasn't yet come in is also with the fact that there is this lack of awareness about how critical runoff is. Just to give you an example, though there have been some events like these mass salmon die-offs off the west coast of the US and such situations, but those are quite scarce. And more often than not, what happens is these polycyclic aromatic hydrocarbons start affecting essentially the functioning of the fish itself. And so it affects the growth of the fish, and not just the fish, but all aquatic life. It affects the reproductive ability of the fish. And so essentially, you don't see them die straight away. So it's not that easy to actually identify that it being a problem where you don't see floating fish on like in your rivers nearby. But essentially, it's genetically modifying the way that they function, and that affects them for generations rather than it being a matter of, oh, it's raining, there's toxic levels of chemicals in the water, and fish have died and started floating. So it's a matter of
Okay.
also being almost invisible to a certain degree. And that's why it's quite hard to bring
Yeah.
in regulation, because there's not that much awareness or discourse on it. And that's something that's changing now.
Yeah. And this is a very big loaded question, but what do you think that regulation should look like? Do you think it's on what we do with the polluted water, or do you think do you think further upstream in terms of actually capturing the pollutants on the road, or just removing the pollutants completely from, say, tires, etc. Where, from your experience, where do you think that regulation needs to come in?
So very honestly, like it needs to be at every stage, but obviously, realistically, when you look at the world, it's not that easy to bring it in at every stage right off the bat. And something that a lot of countries have already actually brought in. For example, Oceania already has this. US has it. The EU brought this just last year, where essentially runoff needs to be treated before it is discharged into the water, because it's not a point source of pollutants coming into the water. It's quite hard to bring in regulation earlier than the stage where it's already mixed with the water and then it gets into the drainage network. Things like tire degradation, things like degradation of your infrastructure, that's not something that you'd be able to change as quickly. Infrastructure is still going to age. You're going to have degradation of it taking place regardless of there being regulations on it. It's just going to be a reduction in it, but the fact that these chemicals are going to end up in that water and then get washed through is going to stay the same. So it feels that the best form of regulation coming in the current system that we already have is having treatment on that water before it ends up in the water body. So you limit the damage that pollutant can have on the water body. Yeah.
And you did touch on it previously around that impact on the water body. You spoke about the impact to the genetic makeup of fish. I'd like to maybe just dive into that environmental impact point a little bit more. When these chemicals find themselves in the water body, what does that environmental impact look like?
Yeah, essentially, in extreme cases where you have it affect the aquatic flora and fauna straight out of the bat, is like the fish die-offs event. And but talking about again how rare it is, what happens more frequently is this genetic modification, and that's gonna then progress over generations, and we're not going to be able to make a change to that then once it's too late. And that's going to then affect the extinction of many of these flora and fauna. But part of it also is not to do with the chemicals. It's interesting because a lot of the times what happens in the roadside drain itself is that contaminants start collecting up, and this environment that's created within the roadside drain itself have these microorganisms that have very high oxygen demand. And then once it rains, this is entirely flushed into the nearest water body, and that creates an anoxic environment. There's a sudden increase in the oxygen requirement, and there's a reduction in dissolved oxygen for these aquatic flora and fauna to survive. And so these two situations are like the primary reasons why it's so toxic for the water bodies, destroying the ecosystem that already exists there.
This feels as though it's a challenge that has almost developed over time and worsened with the scale of chemicals used in our everyday. Do you think this is a recent challenge, or do you think that this is something that has always been the case, but we now just have the data to be able to draw a little bit more focus to it?
Very honestly, it's always been the case, but it's funny because, like the point you mentioned, the data becoming more open, like becoming more available, is something that we're still not at the point of. There's still a lack of data available on runoff. That's also something that we are actually working on, trying to bring more data towards the kind of contaminants that kind of get flushed. Like I mentioned, with all of that information that I gave you earlier, all of that has just been with sampling of data that's occurred with someone actually going and collecting these samples, taking it to a lab and getting it tested. But there needs to be this element of real-time monitoring, so you're able to actually create more of a digital footprint of what's happening in the case of runoff. And that's something that's taking place with air quality monitoring as well over time, because that's another non-point source of pollution that's taking place. And the stage that air quality was at 10 years ago in terms of the discourse surrounding it is where water quality actually is coming to right now. To answer your question, I feel like the more we advance in the sources of data collection, the more we advance in the discourse on this problem, is the easier we're going to get to solving it sooner. And yeah, it's existed for the longest time, but we're hitting that peak in the way that you can start seeing the effects of it, and it's only going to get worse.
Yeah. And it sounds as though that sort of roadside drain is almost the first line of defense.
Yeah. Yeah, it's interesting because most roadside drains that are constructed, especially in the UK, where they're called a gully pot, essentially have a sediment trap underneath. So when they were designed, they were meant to be the first line of defense where they're supposed to start collecting these sediments, which actually at that stage, it's interesting to note that most of the chemicals also are attached to the suspended solids. So the hope was that these suspended solids and sediment would start collecting within the gully pot and the water would flow, but that's not the case. Whereas every time you have a high flow event, all of this is resuspended, goes through the pipes and then back into the drainage network. So part of what we do is essentially trapping these contaminants within the roadside drain, making it more effective in capturing this, because then you can use a physical process to pull out these chemicals. But as soon as you let it through the drainage network, they start diffusing into the water. You have the chemicals breaking down, you have them leaching into the water, and then essentially you need a chemical process towards the end of it, at an outflow pipe or a sewage treatment facility, then to treat runoff, which becomes extremely intensive in the amount of resources that you need. So it feels like a roadside drain is like that pivotal point where a lot of it can be stopped.
I would imagine we also probably we'd have to improve our approach to roadside maintenance of these drains and supporting infrastructure. Is there a bit of a refresh needed in our approach there?
Yeah, no, for sure. I think the way that we essentially target road maintenance, at the end of the day, no matter what intervention you have in a roadside drain, it's only as effective as how you maintain it. Because if you don't maintain it, it's just going to end up going back into the system anyway. So part of the way that the maintenance works currently is it's dependent on the quantity of water, where you have flood events, and that's only when they deploy something called a gully sucker here in the UK, where it's a massive truck with a vacuum on the back where they suck out contaminants and so on. But they only deploy this in a reactive sense where you have a blocked drain. But that's something that needs to change, and it needs to become more proactive in a sense where you have a system where this roadside drain has so much pollution and you need to collect the contaminants that have started collecting there, rather than you wait till there's a flood event. So in a sense, it's a mindset shift from focusing on the quantity of water and moving it to the quality of water, because that's at the end of the day what's affecting the ecology in the water bodies.
And again, shifting from that reactive approach following a flood to a proactive approach. And again, there's this age old conclusion of, hey, we need data, right? We just need more data. We need more visibility of what is happening out there in the field.
Yeah, yeah, 100%. But it's actually interesting because another part of what we do is actually collecting different data sets that are quite available right now, where Ordnance Survey has a bunch of data that's available that you can bunch up with some of the lab tests that you have from these samples that have been collecting from the roadside drains, where you can create a model to actually determine which roadside drains have how much pollution and how long it's going to take to collect up. But it's just a matter of nobody's come around to doing it. And yeah, it's interesting because of the fact that there's all these data sets available, there's all that information available. It's a matter of getting those insights and then acting upon it.
There must be like a hackathon project waiting to happen there, right?
Yeah, yeah, we might jump on that train before other people do, just because like we love this space so much and it's just something that needs to happen. But you're right, like it's there's so many different data sets, there's so many different ways of doing this, but that reactive approach needs to change to a proactive approach, and that's going to be pivotal.
So we spoke about a few stakeholders that play a part in this big challenge. What is currently done to tackle this problem?
Yeah, so essentially, right now, there are a few different solutions that are being used to address the problem. You have permeable pavements, you have things like membrane filters that are being deployed into the roadside drain itself. You have filters that are being put at the outflow pipe, again, membraned, or like you have massive hydrocyclones that are being installed in line of drainage networks. But the problem with each of them is that none of them are scalable in a real city environment. Like in the case of membrane filters, they clog up, they reduce the flow rate of the water, and then you have flooding, and that's you're shifting one problem to another. In the case of permeable pavements and things like that, you have these contaminants that actually, because it addresses the quantity of water, looking at the contaminants that start collecting up within these permeable pavements, they actually just act as like a mini landfill within the urban environment. And in the case of these massive stormwater vortex separators, the problem is that they need huge infrastructural overhaul. And in built up cities, that's impractical. So you're left with no real solution and like just shifting of the problems. So it goes back to that point where, because of that lack of data, because of the lack of discourse on the problem and the regulation, it hasn't led to too many solutions being brought in either. But I guess it's that chicken and egg problem where without regulations there aren't too many solutions because there's no business model to rely on, and on the vice versa, without having the data on it, there's no regulation. Yeah.
Yeah. And I guess it's a really tricky one because of the scale of infrastructure required. The length of the road network in the UK, look, it's vast, and the amount of drainage required in order to be retrofitted is makes quite a it's quite a sizable challenge. So it makes it critical to try and intervene at the right part of the process, doesn't it?
Yeah, that's an interesting point because it's actually not the case that every roadside drain is polluting. So it's actually a matter of trying to identify which roadside drains have how much contaminant flow through them, and that goes back to using these different data sets to map out the terrain, map out the way that these pollutants are actually being generated in a certain area, and then being able to identify which roadside drain is more polluting and addressing that with an implementation. So even though there are millions of drains, you don't need an intervention in millions of drains, and it's much more accessible where you just need to target a handful of them and you've prevented almost 70 to 80% of the pollution straight out of the bat. So
Brilliant. You make it sound so easy there.
I wish it were that easy.
So that's the intervention at the drain level. So it prevents those pollutants from entering the water, the treatment process, and then or the CSO prevents the pollutants from entering the treatment process and then ultimately the water supply.
Exactly. So with the stage at the roadside drain, like just using a physical process, then you can use, for example, in our particular case, we just have an internal geometry where it's using two physics principles where you have centrifugal separation, where you have capillary action, and just using these physical principles and the natural flow of the water, you're able to pull out these chemicals, and that then reduces the amount of investment that you need from like a chemical and electricity point of view from the sewage treatment plant, but also from freshwater treatment when you look downstream, that's being collected for domestic use.
That's a really interesting approach. So I guess that's like a physical intervention at a certain point throughout that process. So it sounds as though there are lots of stakeholders involved in this sort of wider picture. But I guess maybe it's a good question to ask is, where should the funding come from to solve this problem from your perspective?
Yeah, I think that's a really good point because yeah, there is so many stakeholders, but at the same time, when there are economics involved, everyone wants to point the finger at each other. Where in the UK particularly, where this problem becomes more convoluted is the fact that the roadside drain is the ownership of a road agency, where you have a local council, national highways, whether it's TfL in the case of London, it just changes from the geography. But essentially the roadside drain is the asset of the road agency, and then the as soon as the water enters the roadside drain, it becomes the problem of a water company because they're in charge of managing that water and the drainage infrastructure. So the question then, because of the fact that pollution is being created in a way that it's hard to trace and go back towards, it's difficult to pinpoint who's at fault. So it's almost easier to distribute the ownership of it across all of these different organizations. And I think it goes back to that fact where, because of the fact that there's a lack of regulation, there's also this lack of incentive for many of these organizations to do much about it. And that's something that's changed in like these locations where you've brought in regulation, and people then are left with no choice but to take action on it. um, But what we've been trying to do is trying to address it from a slightly different angle, where without having that economic incentive directly linked to a regulation, we're trying to see if there is the possibility of water companies actually saving money from using a physical process earlier down the pipeline rather than having chemical treatment further down. And that's something where we're trying to switch that strategy.
Do you see that working? Do you think that's the answer to this problem amongst many other answers?
I think, yeah, like the ideal answer to the problem would be regulation, and that would make everything simpler for like anyone involved in trying to make a change on this problem. But in terms of the current situation in the UK with no regulations, I think that's one strategy that we've been trying to adopt, and it seems to be the one that has most promising results over most others.
It's such a fascinating conversation. It's one of these areas that is so easy to overlook the scale of challenge. But 30% of pollution in our oceans being mobilized from this. It's a challenge that we really need to get on top of. So thank you so much for taking the time to speak to me today. I really appreciate it.
No, it's always lovely to have these conversations, and thank you for having me.